Okay, let's unpack this. We are doing a deep dive today into the technical paper behind the FCTS leaderboard.
Which is a really important new benchmark suite. It's designed to get a holistic measure of large language model factuality.
Exactly. And our mission today is a rigorous expert-level overview. We're focusing on the methodologies, the findings, everything that's critical if you're working in ML or data science engineering.
And, the creation of a comprehensive factuality score is,
Yeah.
well, it's long overdue, especially as LLMs are moving into these high-stakes enterprise deployments.
Right. And factuality research has historically split into two pretty distinct and complicated scenarios.
As,
The first one is that context-aware factuality, making sure responses are grounded in an immediate source. That could be a document you feed it for RAG
or the pixels of an image for a multimodal task. It's about being truthful to what you've just been given.
honesty relative to the provided truth. I like that.
And the second scenario is general world knowledge. That's where the model has to pull from its own internal parameters from pre-training. Or, and this is happening more and more, use an external search tool for things that are new or obscure.
And the FactCTS suite is so critical because most real-world systems need to do all of this seamlessly.
All of it. Exactly. Which is why the leaderboard aggregates performance into one number, the ACTS score.
Which is just the average across 4 sub-leaderboards, right?
Yeah.
FactCTS, multimodal, parametric, search, and then the new one, AFCTS grounding V2.
Correct. And that brings us, I think, straight to the headline result from the paper, the number that really underscores why this is also necessary.
Yeah, let's get right to it. Even for the top model, Gemini 3 Pro, the overall FactCTS score only hits 68.8%.
68.8 plus or minus 2.1%. That is not a high number.
It's really not. That low figure, just under 69%, that's the real hook for the entire community. For you listening, that means nearly 1 in 3 complex factual queries gets an unreliable or inaccurate answer.
And we're not just talking about tiny errors here. This points to some pretty substantial headroom, architecturally and in training, before we can really trust these models in, say, medical research or legal review.
It just shows that doing well on a benchmark like MMLU doesn't really translate to operational reliability, not when the source of truth is constantly shifting between memory, search, and some document you just gave it.
Exactly. So where should we start?
Here's where it gets really interesting. Let's start with the benchmarks that are all about grounding, where the output has to be traceable back to the source material.
So we're starting with AFCTS grounding V2. This is built for those high-stakes enterprise use cases.
Right. We're talking long-form tasks, summarization, complex Q&A.
And across really specialized domains, medical, legal, financial, technical. And crucially, the context documents can be huge, up to 32,000 tokens.
That right there, that tests long context attention, puts it under real stress.
It does. And for V2, they also upgraded the judge models. They're now using Gemini 2.5 Flash and GPT-5 as the primary evaluators.
Hold on. So if they're using GPT-5 and Gemini 2.5 Flash as judges, doesn't that just grade the frontier models with other frontier models? I mean, are you introducing a sort of moving goalpost bias?
That's a fair and critical question. The paper addresses it, though a bit indirectly. The thing is, the judge LLMs are only assessing grounding.
Ah, so not overall correctness against the real world.
Exactly. They're just verifying token traces back to the context document. So the risk of subjective bias is much lower. Using frontier models just ensures that the evaluation of that grounding is as nuanced as our current tech allows. It keeps the benchmark rigorous.
Okay, that makes sense. The methodology is evolving with the tech, but the really crucial update here is this ineligible responses filter. Can you unpack why that's so non-negotiable?
This filter is basically a defense against superficiality. The judge LLMs do a two-step check. First is the content grounded, that's the unadjusted factuality score. But then they also check if the response sufficiently addresses the user's request.
So it's not just about whether a sentence is true, but whether the model actually gave a substantive, meaningful answer.
Precisely. If you ask for the 5 key risks of some new financial regulation, the model can't just say, there are risks involved with this regulation.
Even if that's technically true and supported by the document?
Right. An extremely vague answer like that, or something like wind energy has benefits and challenges, it gets marked as ineligible, and it scores 0. This stops models from gaming the system by just avoiding the hard work of extraction and synthesis.
So for you as a developer, this makes the grounding score incredibly robust. It measures operational utility, not just textual honesty.
That's the goal.
Okay, let's move to FCTS multimodal. This is where that integration challenge gets really intense.
Oh, absolutely. Here, the model has to blend visual input with its internal parametric world knowledge,
So you might show it what? A picture of a historical artifact?
right, or a complex scientific diagram. And the question could be, identify this specific type of steam engine and tell me the year its patent was filed.
That's visual recognition, then straight into closed book recall.
Yep. The data set has about 1,500 of these questions. Detailed visual description, data interpretation, object recognition, reasoning. It's tough.
And the metric here is really smart because it recognizes the inherent trade-offs in generative tasks. It uses a human-authored rubric that splits facts into essential and non-essential.
And that dual scoring system is key. To get a point for accuracy, the output has to satisfy two separate verdicts. First is the coverage verdict.
Which is recall-oriented. Did you include all the essential facts?
Exactly. Then second, you have the no contradiction verdict. This one is precision-oriented. It checks that the response contains absolutely no claims that contradict the rubric, common knowledge, or the image itself.
And you only get a pass if you get both right. So looking at the results, at Table 3, you can immediately see different strategies from different model families.
You really can. It's a classic precision recall trade-off playing out right there on the page. The Gemini models, for instance, they seem to be recall-oriented. They get high coverage scores. Gemini 3 Pro hits 68.4%.
So they prioritize being complete, maybe at the risk of a few minor errors.
Potentially.
Yeah.
And then conversely, you look at the GPT models. They prioritize safety and precision. They have better no contradiction scores. GPT-5 hit 64.7% on that.
So a Gemini model is more likely to give you the whole story, but maybe with a slightly fuzzy detail, whereas a GPT model is more likely to be strictly correct in what it does say, even if it omits an essential fact.
That's a great way to put it. And for developers, that's a crucial distinction. It helps you decide which model to use or fine-tune for a given application.
And they validated these automated ratings, right?
They did. For the coverage score, the Spearman's rank correlation with human judgments was 0.64.
Yeah. Okay, so a 0.64 Spearman's correlation. That tells us the ranking of the models is pretty consistent between the automated system and human judges. That gives you confidence in the leaderboard.
For sure. And for the really safety-critical no-contradiction metric, they got a macro F1 score of 78.2 against human annotations.
Which is very strong. That F1 score confirms the judge models are reliable at catching the kinds of factual errors humans would spot. It legitimizes the whole automated process. All right, let's pivot. We've talked about grounding in an immediate context. Now let's talk about the other side of the coin, recalling and retrieving general world knowledge, starting with FCTS parametric.
FCTS parametric is a pure closed-book assessment. It's all about testing the knowledge that's actually encoded inside the model's weights. And the main thing here is the methodological rigor they use to make sure the benchmark stays tough.
And the key to that rigor is the dual filter on the data collection. First, questions come from widespread user interest, but then they get hit with adversarial sampling.
And that adversarial sampling is really clever. The researchers basically filtered the questions down, keeping only the ones that 5 strong open-weight models failed to answer correctly in a closed-book setting.
So that guarantees the remaining questions are genuinely hard. They're not just simple, memorized trivia.
Not at all.
Yeah.
And on top of that, there's a strict source constraint. All the answers have to be explicitly supported by Wikipedia. This just eliminates any ambiguity about what the ground truth for general knowledge is, since Wikipedia is a huge part of the training data for pretty much all LLMs.
And the criteria for the questions themselves are super strict. A single, atomic fact. An unambiguous answer. Clear specifications for what kind of answer is needed.
And the fact has to be stable, not something that's going to change next month. That level of quality control is what makes the test meaningful.
So when you look at the results in Table 6, you can see the model's internal decision-making process laid bare, especially when you compare accuracy, attempted accuracy, and the hedging rate.
Absolutely. This is where you see that trade-off between confident guessing and calculated hedging. Just look at the comparison between GPT-03 and GPT-5.
GPT-03 had a slightly higher raw accuracy rate.
It did, but GPT-5 hedged way more often. 13.3% of the time versus just 1.9% for GPT-03.
That hedging difference is so telling. It suggests GPT-5 has a much more sophisticated internal, filter. By hedging, it avoids making a confident, harmful error.
And that boosts its attempted accuracy and ultimately gives it a better overall F1 score. In high-stakes fields like legal or medical work, An honest "I don't know" is infinitely more valuable than a confident mistake.
The benchmark is effectively rewarding architectures that prioritize safety through uncertainty.
It is, although we should definitely note that Gemini 3 Pro was the leader here, with a really impressive 76.4% accuracy.
Okay, let's move to the final piece, FCTS search. This is all about using external tools. For this evaluation, they were all interacting with the Brave Search API.
Yeah, and the big challenge in designing this is making sure the question can't be answered from the model's internal knowledge alone. You have to force it to search.
And they used 4 pretty sophisticated strategies to do that, focusing on new information or stuff that requires complex reasoning.
The first one, hardtail, used human-written questions, the kind of thing where the answer is buried deep in the search results, not in the little snippet at the top. It tests real synthesis.
Then you get into the synthetic methods, like Wiki2Hop.
Right. This is where they create multi-step questions by swapping out an entity, say a person's name, with a description from the Google Knowledge Graph. So instead of asking about John Lennon's birthplace,
You'd ask about the birthplace of Yoko Ono's spouse. So the model has to do one search to figure out who that is, and then another search to find the birthplace.
exactly, it forces a multi-step search process. And then there's Wiki Multidoc, which creates queries that can only be answered by piecing together info from several different documents.
That sounds like a real challenge, like trying to answer a complex question using a trade journal, a press release, and a government filing.
It is. It's all about that cross-document synthesis.
And the last one is KG hops.
This creates the most complex questions of all. Synthetic path queries that need multiple hops in the knowledge graph. Things like finding the publication date of the first film an actor ever appeared in. It requires iterative search and applying internal logic.
So it's testing reasoning over just pure retrieval.
Yes, the model has to figure out the sequence of operations and then execute the searches.
And the results in Table 8 are very telling, especially when you look at the average number of searches per query. That feels like an efficiency metric.
It is. High accuracy is the goal, but latency and cost matter. And you see Gemini 3 Pro, again the top performer, with 83.8% accuracy.
It actually conducted fewer searches on average, 3.39.
Compared to a model like Grok 4 Fast, which searched the most, at 4.7, 4 times on average. This suggests Gemini 3 Pro has a more mature internal mechanism for knowing when it needs to search versus when it can just rely on its own knowledge.
It's minimizing those unnecessary external calls.
Exactly.
So what does this all mean? When you step back, the FCTS leaderboard is clearly so much more than a big collection of Q and A pairs. It's forcing models to show factuality across 4 fundamentally different cognitive requirements.
That's the key. It measures multimodal perception, closed-book recall, tool use, and long context grounding, all in one aggregated suite. Its value isn't just in seeing who's most correct, but in measuring the reliable application of knowledge no matter if the source is internal weights, a 32K document, or a search engine.
And for anyone listening who's a researcher, the detailed metrics let you diagnose architectural strengths and weaknesses. You can see that precision recall trade-off playing out clearly. It's the kind of nuanced analysis you need to drive development.
Indeed. And given that the overall FACTS score for the best model is still hovering just under 69%, it raises a big provocative question for the future.
Which is?
Well, achieving high scores in each of these subsets requires different capabilities. So how might future architectures move beyond this simple bolted-on integration, just adding a RAG component or a search layer, to natively handle all 4 types of factuality? How do they do it seamlessly, ensuring robust performance without this constant trade-off between coverage and precision?
That seamless integration of truth sourcing.
That's the frontier.